Question number 5.233. How fast should a car move for the driver to perceive a red traffic light, which is at approximately 70 micrometer, as a green one? And for that, this is 0.55 micrometer. Okay. So in this problem, it is saying that suppose there is a traffic light, it is red now, and a driver is moving towards the light. Okay. So we have to calculate the velocity or speed of driver so that it can perceive this red light as a green light. Okay. So first we can apply Doppler's concept, that if this driver is an observer move towards the source, then it will experience some frequency shift or there is some change in wavelength, right? So the frequency of red light, okay, which is being generated by this source, that frequency can be calculated as omega red is equals to speed of light upon wavelength lambda red, right? And frequency of green light, which is received by this driver, is equals to C over lambda green, right? So it is typical case when observer is moving towards the source and source is stationary. So frequency received by the observer is equals to speed of light plus speed of observer divided by speed of light. Okay, source is stationary and observer is moving towards source and frequency emitted by the source, right? So from here we'll get omega g over omega r is equals to C plus V over C, right? So from here we can substitute in this expression that Vg over Vr is equals to lambda r over lambda g, which is 1 plus V upon C, right? So lambda, from here we can calculate speed, that is lambda r over lambda g minus 1 into C, right? Lambda r is 0.7 divided by, I think I am committing some mistake. This is lambda upon g. So if we'll take on this side, then lambda over g. Okay. Right. Omega g over omega r. Omega g is C over lambda g upon C over lambda r. So from here we'll get lambda r over lambda c. Right. It is correct. Okay. So this is 0.7 upon 0.55 into C, right? So speed of driver is 70 upon 55 into C, okay? And if we'll divide, then we'll get 1 point something, let's take 1.2 C, okay? And where C is 3 into 10 to power 8 meter per second. Okay. So here we have committed one mistake, that this should be lambda r upon lambda g minus 1 there. That's why we are getting this much value. So it is approximately 0.2 C, not exactly 1.2 C. So we must stand correct that this is 0.2 into 3 into 10 to the power 8 minus meter per second, although it is an impossible speed to be attained by a driver.